mode.
Good afternoon, everyone. This is Mr. Taylor at Young Engineers Today. I hope everyone's having a great day. If you can see my screen, raise your hand. Thank you, Eric, Jean-Marc, Jesse, Luke, Marissa, Anna, Jesse, Marissa. Wow. Packed house tonight. Zachary and Sam. Max. All right. If you can hear me, raise your hand. All right. Great. Keller, Marissa, Max. Awesome. All right. Like I said, we were going to start off today seeing if anyone else wanted to share their Flappy Bird game. And then we're going to go into some physical computing aspects today and build into that. All right. If anyone would like to share, please let me know. All right. Max. All right. Let me find Max. And then we'll do Marissa and Seth. Yes, Max. Max, can you hear me? Thank you, Jean-Marc. Max.
So, wait, is my screen on?
No, I'm going to share screens with you now. I just want to make sure I had verbal communication with you first. Okay? Here we go.
I can't hear anything. My screen. Okay, so this is my game. Nope, that's not what I wanted to do.
All right.
Okay. So I'm going to hide that. So, okay. Oh, that was bad. I'm going to.
All right.
Okay, and that is my game.
Can you explain your design, please?
Yes. So what I did is I took the background and I put it all into red, and then so I said when touching color red, move and change Y by -3, so it would move forward and go down. And then, so I also programmed it so whenever it hit one of the green bars, it would stop and show game over and make a noise. And that would be the end of the game. Then whenever you go through one of the yellow bars, whenever you hit one of the yellow lines, your points would go up and you would gain points.
Awesome.
So, and every time you clicked space, you would go up.
Okay. And how did you change the screens? Can you explain that to us?
Yeah, at the end of the each like screen,
Yes.
I have this little blue bar. Do you see that?
Yes, I do, sir.
Okay, so whenever you hit that, the screen changes.
Okay. Fantastic.
Because I said when touching color that, switch backdrop to the next backdrop. And I have 3 different backdrops. One here, one here, and one here, and then my high score page.
Yeah.
So whenever you touch that line, it would go to the next backdrop, and then there's just a different color at the end of each side.
Okay.
And so you just go to another backdrop.
All right. And then how did you get your sprite to start over? Is it because it touches that color?
I did when touching color green. Wait, right here. Play drum for once for 0.25 beats, which is the noise. Say game over. Wait 1 second, then move back to the beginning and stop the script, and everything just stops.
Okay, awesome. Great job, Max. That's an awesome Floppy Max game. All right.
Thanks.
Great job. Thank you. All right. I'm going to go ahead and mute you. You have anything else to say or share?
No, that's all.
Okay, great. All right, we got a few others. I'm going to take over the screen again. All right. I mean, so far, Jean-Marc, awesome job. Max, awesome job. Thank you for both sharing. Let's go with Marissa. All right. Hello, Marissa.
Okay, hi. I I could not get it onto my flash drive. Henry explained it last class, but I could not get it onto my flash drive, so I decided to in the last 30 minutes I've been redoing the entire code like onto Scratch 2.0 so that way
Okay.
you can see it.
Okay. All right. I'm going to share screens with you. All right, Marissa.
Okay.
All right. Marissa is going to show us her version of Flappy Bird. So we have Flappy Bird, Marissa now. Okay. Let me unmute her again. All right. Go ahead, Marissa. Explain it.
Can you see it?
Yes, ma'am. Go ahead.
Okay. So I'm gonna whoops. So that's my code over here, and I'm gonna play my game. So it's not very good.
Oh, looks good. Oh, I see that. That last one's kind of tricky, isn't it?
Yeah.
I would cheat and shrink my sprite.
Yeah, I did, and then
All right, awesome. Can you explain your code to us?
okay. So I put when green flag clicked, I did forever loop. So it was like I have a lot of if thens. So I put right key pressed. I said move 10 steps. I don't have a back key, but I don't think you'd really need a back key.
Okay.
I have a I have and I put key down arrow press change Y by 10 or by minus 10. I put key up arrow press change Y by 10. So and then I put touching color red. It would be that you would have to use a lot more if thens if you were going to do sprite 1, sprite 2, sprite 3, sprite 4, sprite 5, sprite 6. But I put touching color red change score by minus 1. So let me show you something really, really cool.
Yeah, all right, go for it.
So if you want to, you can look at the score.
Oh, it went negative.
I don't know how to fix that.
Huh.
Yeah, it's like it goes really fast. And then what you can do is look, now it's going down because it's touching color green or pink,
Okay.
which changes the score by +1.
Interesting.
See?
Maybe it's something to do with having your code not be able to just sit on it once it only touches it once. If you can add a in change score by 1 if touching it possibly one time. Would anyone else like to comment on how to fix that? All right, Jean-Marc raised his hand. All right, go ahead, Jean-Marc. Marissa, you and Jean-Marc are unmuted. Jean-Marc? Can't hear you there, Jean-Marc. All right, we're having some mic issues. Marissa, can you still hear me?
Yes.
Okay, Jean-Marc, having a little mic issue there. All right.
But can I say something?
Yeah, you got the floor.
When it touches that blue line, the sprite 9 or no, sprite 7.
Yes.
I have I have it go to where it is right now, and I have the score start over. So it's like an endless game you can always play.
Okay.
But I told you it wasn't very good.
No, it looks great. Give yourself more credit.
Okay, my game is like the best game ever.
I like it. Great job, Marissa. Anything else you'd like to share?
No, that's it. Thank
All
you.
right. Thank you very much. All right, Jean-Marc, anything else? Can you hear me now, Jean-Marc? Can you speak? All right, Marissa and Max, Once you, I'm going to switch screens back to me. All right, that's your puppy I see there. Um, all right, anyone else like to share? Anyone else? Raise your hand. Up. Looks like Luke. Luke, go ahead. Would you like to share?
Yes.
Okay. Let me switch the screen over to you. Okay. Let me find Luke. I will unmute you momentarily, Luke. All right. Welcome back, Jean-Marc. All right. Luke, can you hear me?
Yes.
All right. Go ahead. You're up.
I made a scrolling game. This is so far. It's not that good, but it's still in development.
What's the objective here?
I'm developing a cave part of it.
Okay, so you're going to go exploring?
Yeah, you go exploring. There's a ton of glitches in it right now.
Yeah, and also it doesn't help that it's double feeding.
Yeah.
But hey, very cool. How'd your Flappy Bird kit turn out?
Good.
Good. Would you like to show that as well?
Nah.
Okay. All right, thank you very much. Seth, would you like to show your game, sir? Raise your hand if you would like to share, because I know you had it up before. All right. Anyone else? Going once, going twice. Anyone like to give feedback, comments, share something about their Scratch experience? All right. That is the end of that. Now, all right, ladies and gentlemen. Oh, Jean-Marc, go ahead. I'll let you speak. You can give your feedback to Marissa. Go ahead, Jean-Marc. Unmuted.
Okay, so did she figure out the score thing?
I'm going to unmute her, and then you can discuss with her, okay?
Okay.
Marissa, you're unmuted.
No, I did not.
So, wait, if you want to make it so it doesn't get more score, after you hit the pipe thing, you would put a stop all, so nothing will move.
Well,
right.
wouldn't that if you put a stop all, then wouldn't that it would stop the sprite from moving any further? Because what my problem is when it's touching, I put green lines and pink lines for so that way when it touches those lines, the score is increased by 1, and there's 1 between each pipe. So wouldn't that if it stopped? If you put a stop all in there, wouldn't that prevent it from moving any farther? And the game would be
I thought you meant whenever you hit into the pipe. But if you want to fix that, you'd have to make your pipe move and use variables to say if bird alive equals 0, then add score +1 when it hits the edge.
All right, hold on, Max. Like to add in, and then we're gonna get started. Max, you're unmuted.
Okay, so what you can do for this problem is after it takes away points, you can say move the sprite forward to however many how far you need to get to be out of the red range. That way it doesn't continue going.
Oh yeah, that's a good idea. Thank you.
All right.
Welcome.
Great collaboration, everybody. This is the way people work together in the real world to help solve problems. Excellent job. All right, I'm going to mute everyone up here. All right. And we're going to move into Raspberry Pi physical computing now. This is our first lesson of this. What you're going to need with you is your Pi, your breadboard, your jumper wires, your LEDs, and resistors. Okay? Once you have all that material next to you and your breadboard, raise your hand. You should have received this material from either Mr. Dubik or myself and Mr. Dubik. Okay, Jean-Marc, Jesse, and Zachary. All right, once you have it, Sam, thank you. All right. All right, everyone. Okay, Alex is going to get his. All right, what we're going to be doing is using the GPIO pins, the general purpose input-output pins. All right, Marissa, I know you can't raise your hand. Just text in to me that you have it. Great. I see that you have yours. Excellent. All right. Max, type in. Let me know. Any of those are presented. Luke, Max, when you have to present, you have to type in the panel. So just text me if you have something to say. Keller, thank you. You got yours. All right. Okay, Annie has hers. I just want to make sure everyone has these. So we don't have to backtrack because you're going to need these. What we're going to do basically is use your Pi as a power source. Outside, Alex got his, great. Okay. All right, I think we have the majority of people here to move forward. All right. As I said, we're going to be using GPIO, general purpose input output pins. This area is the pins that's to the left of your SD card holder and reader. All right. And here is a top view of what we're looking at. These are the pins that you will be using. Okay. Put hands down. I think everyone has theirs. All right. Now, from an up-close view, these pins give us the ability to use our Pi to power breadboards and create circuitry and also power other add-on attachments that you might want to use with your Pi, such as different variety of hardware. Adafruit has a variety of different things, for example, that you can use with these. And these are called, once again, general purpose input-output pins. Okay? All right. Now, all right, there's basically two ways that you can look at this, and this is basically a schematic of your GPIO pins. You have these pins are running in numbers, so you can either do pin numbers, which they go 1 to 2, 3 to 4, 5 to 6, 7 to 8, 9 to 10, 11, 12, 13 to 14, etc., all the way up to 26. Or you can do it by GPIO numbers, which, as you can see, 11 would mean pin 11 equals 17. Pin 1 equals 3.3 volts, which is a little bit more than 2 AA batteries. All right. Then, as you can see, we can use the same terminology to define something the same way. Great job, Luke. See, you got yours. All right, Luke, remind Mr. Dubik to give you one, okay? All right, I'll repeat this one more time. Let me start over because I asked the request to repeat this. We're using the general purpose input and output pins, okay? General purpose input output pins are right here. And this would be 1, where I'm pointing. Above it is 2, 3, 4, 5, 6, 7, excuse me, and so forth on. The ones that are on the inside, closest to the SD card, those are your odd. On the outside, facing away from the Pi, those are your even. That's one way you can look at it. Now, those pin numbers match up with GPIO numbers. So if you wanted to call them by GPIO numbers, you can see it that way. That is another way. If you want to turn your head to the left while you're looking at your screen and read it that way, it'll help you read the GPIO on it, okay? All right. Now, does anyone have any questions about this? Okay, Max. All right. Yes, Max, go ahead.
How do you know which is which? Like looking at the Raspberry Pi.
If they are even or odd pin numbers.
Okay.
If they're, well, I'm asking you a question. Is that what you're
like, how do you know which pin is what number?
Okay, here, look, I'll look at it this way. Let me go back to the previous screen. You see where my arrow is right here?
Yeah.
You see this P1?
Oh, is that 1?
1. What would this be above it?
2,
What's this down here?
3, 4. Okay, I get it.
Okay, no, that's a great question. All right. And then, do you understand how we have corresponding just GPIO? It's another way of phrasing it, okay? All right. Okay, thank you, Max. Marissa, you have a question? Yes, Marissa, go ahead.
So I don't get how the GPIO things, the pins, little pins sticking out. I don't get like what they have to do with a breadboard.
All right, they are. If you let, can you stay on the line for 1 second?
What?
This slide right here tells us what we can use the Pi as a battery or power source.
How can you do that?
Through these pins. These pins, the Pi has power running through it. We can extract power from it, and we're going to wire it into a breadboard, and instead of using a battery to wire into a breadboard.
Okay, so can I ask a question?
Yeah, go right ahead.
So the power that's coming from, see, I have my power plugged into the power strip thing.
Okay, and your power strip's plugged into your power outlet.
I just have a question. So the power coming from the electricity that we have at our house can go through the Raspberry Pi and it can power the breadboard thingy-majiggers?
Yes, exactly.
Okay.
Basically, we are going to use your jumper wires to jump power from the Pi off of these pins into the breadboard and make circuits.
Like you would do if the car needed a jump.
Exactly.
Okay. Thank you.
Okay. Excellent. All right. Mute her. All right. Anyone else have a question? Okay. I'm going to assume everyone else is okay and understands this. Raise your hand if you understand this. Sam, Jean-Marc, Marissa, Max, Keller, Zachary, Seth, Alex, Anna. All right. Now, we're going to be looking at basically, it's called fritzing. They're like digital schematics of the Raspberry Pi. And another way, if you look at it, if you turn your head to the right, here's a digital view of it. Just a review. We can refer to them as pins, or we can refer to them as GPIO numbers. And we can use the 3.3. Now, if you notice, how many grounds do I have on the? Can someone raise their hand? See if you guys can read this. How many grounds do I have? Put your hands down. All right. How many grounds do I have? Come on, Jesse. Go ahead, Jesse.
5.
5. Very good. And Jean-Marc and Zachary are correct as well. They typed in their answers. All right. How many 3.3 volts do I have? Someone raise their hand and tell me that. How many 3.3 volts do we have? Let's go with Eric. Yes, Eric?
2 of them?
Excellent job. Excellent job. Now, how many? Let me see here. The one thing I want to point out to you, I'm going to go back a slide. There are a 5 volt. We do not use the 5 volt. All right. The 5 volt pulls too much power from your Pi, and you could cause damage. Okay. So only use 3 volts. And if you try to power too many things, as I've done and learned through experience, it'll draw so much power your Pi won't actually function correctly. So those are just a few things to be aware of. All right. Now, a circuit. A very basic, simple circuit. Can someone describe to me what is happening in this simple circuit? We did circuitry and like with snap circuits in the fall. Can someone describe to me with their hand raised what is happening here in this image? All right. Thank you, Jesse. Go ahead, Jesse.
The power is running from one end of the battery into the light bulb and goes back into the battery?
All right, back into the battery. Exactly. Very good, Jesse. This is a simple circuit, and technically this is a series circuit. It goes from, you have your negative end, it goes in, runs into the light bulb, runs out of the light bulb, and into your positive side of the battery. With breadboarding, you can create circuits, and that's what we're going to be doing with your Raspberry Pi, okay? Now, with an LED, all right, we know that LEDs are diodes, okay? And what is special about an LED compared to some other parts? All right, can someone let me know? Let's go with Zachary. Go ahead, Zachary.
The energy can only flow in one direction.
Very good, very good. And why is that from just looking at this image?
Because it won't light it up.
Okay, I won't light it up. Would anyone like to add on to that? Thank you, Zachary. I see Marissa has her hand raised. Yes, Marissa.
Oh, I'm sorry. I've typed in for the last question. I'm not exactly sure for this one.
All right. It has a positive and negative side, all right?
Oh yeah. Okay.
Due to its characteristics. Now, a lot of times you're going to make mistakes and plug these in. But one of the best ways you can tell is by some physical characteristics. You have a long side and a short side on your LED. So pick up an LED and look at it. And you'll notice that the short side is the negative side and the positive side is the long side. Also, now look down on it. and your LED will have on one side a flat edge. That flat edge also signifies the negative side, the cathode, the positive side, the anode. All right. Now, we have our breadboards. Breadboards allow us to do some experimenting, prototyping, etc. with creating circuits. Now, if you notice, there are letters and numbers that run on these, showing you that you have positive and negative sides, as well as helping identify. Just like you would do with graphing, you have A1, B1, C1, D1. You have A1 through 30 on this one. And then on the next side, you have F1, so forth and so on. Okay, so you can be able to identify and label, which is important here. Okay. Now, the power runs in two different ways. Rails will run up and down, and then with on the inside, these will run left to right. Okay, so it's something to be aware of when you're plugging them in, how you can connect your power. Here's another way of looking at this. As I said, numbers and letters for referencing, all connected, a bus running up and down, and we have groups. Now, when we're inside here, I want you to be aware of this. We're inside, and I put a pin here and a pin here. They're not going to power each other. Okay, power is not going to be transferred. Only in groups of 5. Okay, they're not connected vertically. Now the difference out here is that these run up and down, where I transfer power. And that's what I'm referring to, is almost like a wire. They have metal inside the bottom of it. And when you're using these, when you're pushing resistors, LEDs, wires, etc., make sure you push it all the way in, so you're making that connection with your two conductors touching each other, okay? And this is what I'm talking about. If you pull it apart, you see that there's copper metal inside here, plate, and you can be able to you touch the ends of your metal, whatever you're using, to have that conductive relationship, so energy, electrical energy, will be able to pass on, all right? And that is a mistake that I even do sometimes. I just don't push everything in. And I thank you to all those who are participating and typing in. All right. All right. Now, what I need you to get is your red jumper wire. All right. In your breadboard. What you're going to do here is get the resistors that we gave you. All right, and the where you can tell which resistors you want to use is the one where Mr. Dubik and I gave you like 3 to 5. We want to use one of those. Okay. What you're going to do is take your red jumper wire. On the pin, you'll plug the female side onto that, and then run the male end into J9. All right. So go ahead and do that. And once you've done so, raise your hand. And the thing is, if you don't want to, if you're confused by which hole to plug it in, just try to make it look similar to this, okay? Yes, Anna.
How do you know which one's female and which one's male?
Okay, you want to use the male side, which is the pin that's sticking out. The female side you will plug into the GPIO.
Can you say that again?
The one end, we gave you 2 sets of wires. One has a hole in it. You'll use that to plug into the 3.3 on the GPIO. And then the other wire has the end where you'll plug into the breadboard.
Okay.
Okay? Look at it this way. Think about it as like you're doing those like puzzles when you're a kid. You had to shove like different shapes into different holes. You want to match. The pin has to go inside a hole off the GPIO, correct? Then the breadboard, you obviously are sticking something inside of it. Does that make sense?
Mm-hmm.
So you'll plug it in. All right? Very good. Thank you.
Mm-hmm.
All right. Sam, you all done?
Okay, I don't have a red wire, and also, which side of the resistor goes in? Like, does
All
it
right,
matter?
we're going to do this one step at a time, Sam. Okay? So if you want to work ahead, I don't want to get anyone confused. So if you're working ahead, just try to pay attention to the image, okay?
Okay.
All right. Thank you, sir. All right. Yes, Marissa.
Okay, so I am completely lost.
What are you confused on? I need feedback to help you.
So right now I'm supposed to be plugging the red wire. I have 2 red wires, but one doesn't have like a hole in the other end.
Okay, you need one that has a hole on the end and one that has a point on the other end.
So one wire, but it has on one end it has a hole, and on the other end it has a point. So I have
Yes.
that.
You need
Okay.
2 of those. If the colors aren't the same, I'm fine with that. Whatever you have, okay?
So but they don't have to be red.
No, if you don't want, I'm just trying to keep it with negative and ground.
Okay, I've got a yellow, an orange, and a brown. I don't know.
Just use 2 different colors, all right?
Okay.
We'll call it safe, all right?
So what do I do with them? So I know that I plug the ends into the GPIO.
Okay, what's
Points,
the
but I don't know
instruction
where.
say? What does the instruction say on the screen?
Connect the red jumper to 3.V to J9.
All right, so in 3.3, looking on the Pi, is pin 1.
Did you say 1 or what?
I said pin, P-I-N-O-N-E.
This is so confusing. So I think I got it.
Pin 1. Which one is pin 1? You actually even have a logo on your Raspberry Pi for it.
Oh, does it say PI? I mean, no,
Yes.
P.
1.
Yeah, P1.
That is pin 1. That is 3.3 volts.
So the one closest to the SD.
Yes, ma'am. Exactly what we said
Okay,
earlier.
I'm sorry. This is just confusing.
No problem. Just trying to help.
And wait, what about the ends of the wire? Do I plug them into the breadboard, or
What does it say on the screen, Marissa?
you should be using the male to female jumpers?
J9. Look at the letter on your breadboard.
Oh, okay,
Find
sorry.
J, scroll down to hole 9. Okay?
Okay,
All right.
thank you.
No problem. All right, Jean-Marc. All done? Need help?
Yeah, I finished the circuit and my LED lit up. Is that what it's supposed to do?
It lit up? Yes, you just worked ahead. That's fine. All right. Jean-Marc, what I would challenge you to do, see if you can light up another LED.
Okay.
All right. Now, don't use the 5-volt pin, okay?
Should I use another resistor?
See if you can do use a circuit off of this. Build it off of it, all right? You can
Okay.
experiment it, okay, since you're working ahead. All right. Thanks,
Okay.
Jean-Marc. All right. Zach, all done?
Yes. How do you put the resistor in?
All right. Can you hold off 1 second so we can move to the next step, and I'll tell you.
Uh-huh.
All right. Thank you. All right. Anna. Anna,
Yes.
you had your hand raised.
Oh,
All done. Or you need help?
It might have been raised from last time.
Okay. You doing all right?
Yep.
Okay. All right, everyone. Let's move ahead. All right. Now look, resistors. The resistor we're going to use is a 540 ohm resistor. Basically, you have this one. I don't believe we gave you any other ones except this, so you should be fine. Now, the way you plug a resistor in, you have two ends, and where these are not my nails, and the other. Bend them down because they're wire. You can make them flexible, and you will pin them in. Put pin 1 in H5 and push it in, and push the other in H9. Okay? All right, hold on, Marissa. I'm calling you. Yes, Marissa?
Okay, I was wondering which one goes into J9? Because there's only one J9.
All right. Are you talking about, if you notice, this is just building on top of each other. It's the previous steps.
No, I was talking about the thing you just helped me with.
The
I
pin
I
1.
don't
Pin 1.
what?
Pin 1.
Okay.
All right. Use pin 1. We'll go into J9. Okay?
Okay, but I also have one more question.
All right.
So, is there supposed to be another wire next to pin 1?
No.
Okay.
Nope. And that's the reason I was trying to have you do it one step at a time, okay?
Okay. And about the resistor, how do you know like which side to put?
It doesn't matter. It's not like a diode. You can just plug either one side in.
Okay, thank you.
Oh, you're welcome. Okay. All
Mr.
right.
Taylor?
Yes. Oh, I left you mute. Oh, I'm sorry. I apologize. Okay. Zach.
Mine worked, and I connected the one half of the resistor to G9 also, and it still worked.
Okay, and the reason why I look at this, I'll show you. You see how they run? Remember, they run in groups of 5.
Yes.
So even if you have it here, you had it in G. Do you see how it lights up this whole green area?
Oh, yeah.
Yeah. Now, the thing is, that's the reason you can do that. All right? As long as you have it in 9, you're not going to have any problems. But good practice is keeping it organized. Okay, Zach?
Mm-hmm.
All right. Go ahead, Jean-Marc.
I did it.
Excellent.
I lit them both up.
Did you use another 3.3 or did you?
I used it off the same 3.3.
Okay, so you jumped it into the next one. All right, very cool. Very cool.
Yeah, at first it didn't work because I used the big blue LED and a green one, but then I switched the big blue one out with a.
All right, well, just keep
One
experimenting.
worked.
All right.
Okay.
See if you can do 3 LEDs now.
Okay.
All right, thank you, Jean-Marc. All right, everyone. Let's move forward. Now we're going to take your LED. Did I not? Hold on, I need to fix something right here. I made a mistake when I made my presentation, so I want to fix it. All right, and for Marissa, I will go up here and make a change for you. And I'll put pin 1. Okay. And then I'll put down here. Two different colored jumper wires. All right. Good. All right. Now, what you're going to do is take LED and put it in I4 and I5. Now, make sure you have the positive side in I5. Okay. Or the negative side. Just try it on which way you want to. Just try it out. Okay. And yes, Marissa?
Oh, the COM was from the last one, but I was about to type in COM. So, this is so confusing. It's hard to, so the LED that we just put in, it's supposed to light up, right?
Nope, not until Jean-Marc and Zach and a bunch of them are working ahead. So don't worry about them, okay? Just worry about what we're doing one step at a time.
And the positive is the long side, right?
No, that is yes, the positive is the long side. The short
And it goes in 5.
Yeah.
Sorry, that was my dog.
No problem. Look here. We'll even go back. Yeah, positive long side, negative is the short side, and we will put the positive side in 5 and the negative side in 9. Okay?
Okay, thank you.
All right. Would you like me to add that onto the presentation slide?
Yeah.
Okay. I'm just taking feedback. All right, if it helps.
Wait, am I? Okay, I'm still muted.
All right, I just want to say if you like the wording on this.
Okay, but I just.
Yep.
I was wondering. So you bend the LED and you put the positive in 5 and the negative in 9.
Yes. Yes.
Okay, thank you.
Oh no, excuse me. That's the resistor. Sorry, that was the wrong slide.
Oh, so you put the positive in 5 and the.
Yes,
and
5 and 4. Yes.
Okay, thank you.
You're welcome. All right.
Sorry, my mom just got home.
No problem. All right, Max, go ahead. You having problems?
I was just wondering, so ours is not supposed to be lit up right now, right?
No, because we haven't completed the other end of the circuit.
Okay.
All right.
Okay,
If you're
just
following along with me,
okay.
don't worry about like Zach and some other people. Okay.
Okay, and does the resistor have positive and negative sides?
No, it's just universal. You can use it in either direction. Okay.
Okay.
Thank you. All right. Sam did it. Great. The hole will be on the end of the wire. All right. And then on the hole on the breadboard. Okay. Now the last step, use another jumper wire. Okay. We are going to connect it in F4. Not me. And this will be pin pin 6. Now, we're going to take it from F4 and plug it into pin 6. Okay? Yes, Jean-Marc.
I just had a question. Is it okay to, since you can't use the 5 volt because that draws too much power, is it okay to use two 3.3 volts?
Yeah, yeah. Go ahead and notice that you have other grounds too. All right.
Okay.
Okay. Yeah. Just remember we have five grounds. Okay. Thank
Okay.
you, Mark. And Anna, go ahead.
I got my LED to light up.
Congrats! Great job. Nice.
you.
Very good,
Oh,
Anna.
and I have a question.
Yes.
Do we bring our pie to our lab this weekend?
Yeah, go ahead and do that. I'll pause real quick. Everyone who has a lab this weekend with Mr. Dubik and Raleigh, please bring your pie stuff with you this weekend as well. Okay?
Yeah, thank you.
All right. Thank you. All right. And the last thing we're going to do, ladies and gentlemen, I'm going to put this up here before we run out of time, is turn your Raspberry Pi on, okay? And you should have this up and running. All right. Yes, John Mark.
My hand was still up, I guess.
Okay, I apologize. All right, let me call a few people then. Thank you. Max. Max.
Okay, mine, I've done everything and it didn't turn on.
All right. What pin is your negative end plugged into?
My -6.
Okay, it should be in pin 1.
Oh, sorry, yeah, that one. Okay.
All right, your ground should be plugged into pin 6.
Yeah.
Now, do you have your resistor in the right location? H5 and H9.
Yes.
Turn your LED around.
Okay.
Keep it in 4 and 5 of I, but just turn it around. Pull it out and turn it around.
Okay, I'm doing that right now. Still off.
Did you check to see all your pins are pushed all the way in?
I'm going to do that right now. In.
I don't want them looking like they're in. I want you to push, good push on all of them.
Yeah, I did.
Okay. Now, make sure, pull out your LED, take the long side and give a good shove into I4.
I4.
All right.
Okay.
Now take the short end and give it a good push in I5.
Okay. Still not on.
And your pin, your SD card's right here, correct? Or incorrect?
Yeah.
And this is going from the pin that's near, pin 1 is near the SD card.
Yes.
And it's going into J9.
Yeah.
Which resistor? Do you have?
What?
All right, I'm going to show you a resistor. Is this the resistor colors that you have? Gold, brown, blue, and green?
Yeah. I
Try
think
it.
so.
You think so? Double check.
Gold, brown, blue. Wait. No, I don't believe so.
All right, get a different resistor out of your bag.
Okay.
Because if you have a stronger resistor, it's going to evaporate basically your energy.
Okay, I'm putting it in.
All right.
Still not on.
Change out the LED.
Okay. And it's the red LED?
It doesn't have to be red. Just use a different one. Because if that LED is broke, it's not going to work.
Okay. Still not on.
All right. Do you have a camera on your computer?
On my computer, yes.
right, I'm gonna switch screens with you. Can you please use your camera, turn it on,
Yeah.
show me what you have there?
I'm gonna go onto photo booth.
Okay. All right, everyone else, have a great night. Have a wonderful weekend. If you're in Raleigh, you'll have a lab this weekend with Mr. Dubik. I'll have the video posted later tonight. Have a great night, everyone. And as always, thank you for being part of Young Engineers today. Have a good evening, everyone. You may sign off. I'm going to be trying to help Max now. Good job, Sam. Bye, Zach. All right, John Mark. All right, hold on 1 second, Max. Yes, John Mark.
Okay, so my LED, I unplugged my Pi because my LED started freaking me out. I forgot to put a resistor, and my LED started smoking.
Yes, you burned it out.
Yeah, because
And you
it
want to
now
be very
smokes
careful with
everything.
that, doing that with your Pi, okay? You're
Yeah.
just going to have to get your own resistors going, okay?
Okay.
All right. I'm gonna mute you now. And now Max, I'm gonna unmute you. Max, can you talk? Okay.
Okay, so this is what it looks like.
All right. You see that pin? This pin that's above the green
Right
LED?
here?
Yeah, no, the other one, the brown one.
Right here.
Can you move that down so
This
that move it down one so it runs in the 5-way with the LED?
Yeah.
It should be in the same 5 holes running horizontally. You want that connected?
It is.
Okay, it is. All right, hold it back up then, sir.
Wait, no, they're both in 4.
Okay, so they're all together running on the.
Oh, no, okay.
Is
Okay, I
it,
just did that.
are they both in 4 or 5?
5.
Let me look at my image. So, all right, hold on 1 second. All right, put the LED, put that ground pin in both in. They're both in 4 now, right?
They're both in 4.
Okay.
No, they're both in 5.
Okay, put it in 4, please. I want it in the same as the LED in 4. Okay.
That's where it used to be.
Okay, I just want to make sure. I'm trying to check everything. Okay. All right. Now. All right, pin 1. Where is it going? It's in J. What is it in?
It's in J9.
Okay. It's in J9. Very good. All right. Now, your resistor. Is it in H5 and H9?
H5, H5 and H8.
Put it in H9.
Okay, that did not help. It didn't do anything.
All right, now, all right, hold it back up. All right. The next thing is, okay, we got that. Good. Now, your 3.3 coming out of pin 1, is that in J9?
Yes.
All right. Okay. And you said the LED is in I4 and I5?
I4 and I5, yes.
All right. On your GPIO, can you push those pins all the way down on your Pi? On pin 1 and pin
yes,
6?
I just did that. I just did that.
You're
Nothing
still-
happened. Wait, actually, one of the pins seems really loose, but when I pull it, it doesn't come off easily.
All right. Oh, is that on
Yeah,
pin
that's
Is
with both.
that pin 1 or pin 6?
Okay, they're on. What?
Is that on pin 1 or pin 6?
It's on both.
All right, push them down further. Like try to get them all the way to the base of it.
Okay, did that.
Huh. You're still not getting a connection.
No.
Push your LED in a little bit more, if you please.
Doing that.
All right, now hold your hand around the LED. Put it down and hold it down and see if it's lighting. Like put your hand around it and see if you're getting a glow.
No.
All right. Okay. You're setting it up right. I don't. What I would do is leave it like that, and I can try. If you can do this, you got like an iPhone or something.
Yeah, I have an iPad in my house. Should I go get it?
Take in the meantime, because I gotta help a few other people, and then I gotta go because I gotta do another lab. What I'd like you to do, take pictures of it, like close up pictures of what it looks like, and send it to me, and I'll try to see if I can give you some more feedback that way.
Okay, you know what? I'll just do. Can I just take a picture right now on Photo Booth?
I don't know if I can see it. Yeah, you can try that. Go for it. I just don't know if you can zoom in enough. Sam, how can I help you?
Okay, so I was just wondering, did you ever figure out how to get the taskbar back on the Raspberry Pi?
No, I've looked around. I don't know what's going on there.
All right.
Did you find anything in your research?
Not really. I mean, I got it got it to work a little bit, and then I shut it off, and then I came back and turned it on, and it didn't work.
Okay.
It's back to how it was. So.
Okay. All right. Okay. I'm sorry. I'll try to look some more and see. Ask Mr. Dubik if you will on Saturday.
Okay.
All right. Thanks.
Thanks.
Okay. All right, Max. The resistor. Let me look at the resistor. Do you have a resistor that has blue in it?
1 second. I'm just taking a picture. A resistor that has blue in it. Yes.
All right. Can you plug that? Is that the one it's plugged in? The image you just took? Does that resistor have blue in it on the breadboard?
Yeah. See, this is the picture.
Okay. And do you have any other resistors? Can you hold them up? The other color resistor?
I have 2 others. Okay, so I have that one. Do you see that?
No, it's too blurry. What colors are they?
Gold, brown, blue, and red. Or no, that's a green, not a brown.
Try that.
Gold, red, blue, and green.
Put that resistor in, please.
Okay, it's the same colors as the other.
The one you have
I have in.
Okay.
Yeah.
All right. We've tried the other LED. We tried a different LED.
Yeah.
All right. Okay, Max, I'm tapped. I'm gonna have to ask someone else. Okay.
Okay.
I'll talk with Mr. Dubik and see what ideas, and I'll call my professor friend who works with these two.
Okay, and then in the next lab, I'll bring it in, and you can help me also.
Yes. Also, try another ground. We can try that. Put the ground in pin number. Instead of pin 6, let's move it to. No, leave the ground at pin 6. Let's change pin 1. Actually, let me get another view on
Oh,
this.
whoa, what happened? Okay, sorry.
All right, move pin 1 to pin 20. No, see, 7, 8, 9, 11, 13. To pin 17.
Okay, 6, 8, 9, or no, 8, 10, 12, 14, 16, 17. Nothing.
All right, now move the ground to pin 20. Or the, yeah.
18. Okay, still nothing.
All right, and you have your Pi plugged in?
Yeah.
What's
Yeah.
powering your Pi?
The TV, which is on, and then the power hub is also plugged in.
Okay. All right. I'm top max. I can't think of anything else. All right. I'm sorry. Oh, yeah, we'll try to fix it
That's
next
fine.
week. All right. Thank you, Max. All right.
Okay.
I'm gonna go ahead and change it back over. Okay. Mute Marissa. Yes, Marissa. Marissa, go ahead.
Thank you. Okay, so I have a couple questions.
Okay.
So I have, wait, where'd that tiny little thing go? Okay, so I have two different sizes of resistors. Which one should I use? The bigger one, which the colors are gold, red, blue, and green, or the smaller one?
What's the colors on that?
Brown, black, orange, and gold, I think.
Use the first one that you described to me. The green, blue, red, gold.
Okay, and which, that goes in H5, and, wait, no, not H. What does it go in? F, or?
Hold on one second. It goes in H5 and H9.
Okay, that's what I thought. Okay.
Anything else?
Yes.
Okay.
Let's see. H9, there it is. Wait, did I get it right? I think I did. Okay. So, now that I have that plugged in, so I need another wire, and where'd it go? Oh, here it is. And where does that go?
It goes
Like,
in pin 6.
How can you tell which one is pin 6?
If pin 1, and they go, when you count up, like I told you earlier, evens are on the outside, odds are on the inside.
So it's like 2, 4, 6.
6. Yeah, exactly. Killed it. Nailed it.
Okay, and that goes into what?
That goes into F4.
There we go. I got it.
Excellent. Very good. All right, Marissa.
Thank you.
Fantastic. You're welcome. Have a good night.